Hi everybody. So in today's video, I'm going to be programming the Rough Heston model, and it is used on a stock which has a Hurst exponent of less than zero point 0.5. So let me go ahead and load the stock data. So in order to do that, I need to add some libraries. So I'm going to include boost slash property tree slash p tree of HPP. Include boost property tree of JSON underscore parser dot HPP and include string stream, so S stream, and then include algorithm. Okay, so now what I have to do is come over here and then define my stock function. So I will do std map of std string and then a vector double, and I will call this financial data. So it's going to take an argument of a ticker. So then what I'm going to do is copy this map. So Command C, Command V, and call it result. Return result. So let me call it down here. Um, so I'll call it data equals financial data of ticker. So let me go ahead and make my ticker as well. So that's going to be string ticker equals Starbucks. Because I did like a pre-screening analysis where I found that Starbucks has the Hurst exponent less than zero point 0.5, so it'll be able to work well for this video. Um, so yeah, let me now come to financial data. So I will do std string of response equals request. So request of historical data, and it's going to take the argument of ticker, and then I'll do std string stream ss, which is going to cut response up, and then I'll do ptree df, and then read underscore JSON of ssdf. So now I do for ptree. Oh wait, I forgot something. I have to do using namespace boost property tree. So that way I won't have to call like the long name. It'll just make it efficient. So ptree of constant iterator iterator it equals df dot begin. It is not equal to df dot end plus plus it. I didn't need that. So this is a Python list, or rather just a regular list that comes. So I have to define an inner ptree constant iterator to go over the specific price. So this, wait, I misspelled it here. Ptree. So this will be for ptree constant iterator of jt equals it second dot begin. Jt is not equal to it second dot end plus plus jt. So if jt first equals price, this will be result of s dot pushback jt second dot get value of double. So now I have the stock prices. So now what I want to do is calculate the returns. So that's going to be for int I equals 1. I is, oh, actually, no. First I have to reverse these. So std reverse of result s dot begin, result s dot end, and then for int I equals 1, I is less than result s dot size plus plus I, and this is going to be result of r dot pushback of result of s I divided by result s, and then I minus 1 minus 1.0, and then return result. So now that I have that, let me go ahead and print out data of S of 0 and then data of R 0 and that line. So now I'm going to come here and do g++ r heston.cpp c++17 and lcurl. Okay, ./a.out. Okay, so I've got the latest Starbucks price and the rate of return for that element. So I don't need this anymore. What I'm going to do now is I'm going to come over here. So I need to program the gamma equation. So I can program this using the Simpsons method, but I don't want to spend too much time like going through with it. So I'm just going to write, can you program the gamma function in C++? Okay, well, according to Google Gemini, this is, no, I mean Claude. Okay, this is a lot. All right, this is what I'm gonna do. I'll keep that, but let me minimize this. Let me do for int I equals 0, I is less than 10 plus plus I, C out of gamma of I. Because I know what the gamma function looks like I know how to solve for it. So I'll verify whether this is the correct one. Gamma is depreciated. Wait, what? That was just a warning. A dot out. Okay, yeah, seems about right. So I will keep that. Um, so now what I'll do is, oh shit. I'll call it big gamma. Yeah, so I won't get that warning. Let me go ahead and recompile it, see if I get that warning. Gamma depreciated. So let's see. Gamma. I guess that was it. So I don't want these warnings. Okay, good. All right, so we can move on from gamma now. So okay, so got gamma. Now let's work on the Hurst exponent. So this will be double Hurst, and it's gonna take the time series of ROR. Um, okay, so I realize I have to program functions to calculate the mean and the standard deviation. So I will do double mean e of std vector double. I'll call it x double total equals 0 for auto and I in x. Total plus equals 1 I. Almost made a huge mistake there. Return total divided by cast double x dot size, and then double stdev standard deviation vector double x again. So double mu equals mean of x, double total equals 0, and then for auto and I in x again, total plus equals the power of I minus mu squared, and then it's going to be total equals total divided by cast double of x dot size minus 1, and then return the power of total to 0.5, square root it. So we've got the mean and the standard deviation. So the first thing I'll do is mean mu ROR equals mean of ROR, double SD ROR equals STDEV of ROR, and then I'll do double C sum equals 0, STD vector double of store, and then it's going to be for int I equals 0, I is less than ROR dot size plus plus I is going to be csum plus equals ROR of I, and then store dot pushback is going to be csum minus mu of ROR, and then over here I'm going to do, let's see, I could, oh, okay, let me come up here, yeah, I have algorithm already, let's see if this will work. So let me go ahead and return 0.0. Let me come over here. So I'm going to come over here and do Hurst of data of R, and then I'm going to, let's see, okay, so the standard deviation. Let's try this. STD sort of store.begin, store.end, and then for auto and I in store. This will be cout of I and line. So let's see how this works out. So I'm going to come here, compile it. Hopefully there's no errors. Oh, good, no errors. So dot slash a dot out. Okay, so now that I have that, I can just simply do double y1 equals store of 0, double y2 equals store of store dot size minus 1. So cout y1 y2. Let's just make sure this works before like returning the Hurst exponent. So clear that. Dot slash a dot out. Okay, perfect. So now I will come over here and do double Hurst equals, so this is going to be the log of y2 minus y1 divided by SD ROR divided by the log of the size, so it's going to be ROR dot size. So return Hurst. Okay, so now I'm going to come here and call this H equals Hurst, and then I'm going to print this out. So cout Hurst H and line. Run it, or I mean compile it. Oh wait, my mistake. Yeah, I get too attached to Python, then when I go to like languages like this, I just mess up. So clear that. A dot out. Okay, good. So this is a valid stock to use because the Hurst exponent is less than 0.5. So now let's move on. So I got the Hurst, I got gamma. So now that brings just the actual equations. So don't be intimidated by these, and I'm telling that to myself as well. So we have to integrate this. So in order to do that, we have to go from 0 to t, and t is the variable for the paths. Hold on. This is a little confusing because like I haven't had to do like an integral. This might be like a separate integral over time. Um, okay, so yeah, let's just break down the components. The first thing that I'm gonna do in this is I'm gonna I guess compute the kernel, the fractional kernel. So because I already have the Hurst exponent and I already have gamma, so I will call this double of kt, and it takes the argument of t. So it's going to be return of the power of t to the, oh wait, I need to include the Hurst exponent as well. So t to the power of h minus 0.5 divided by gamma of the Hurst plus 0.5. Okay, so I've got k of t, that's good. So I'm going to loop through this. What I'm going to do is come here and do for, let's see, for int t equals 0, t is less than 20, plus t, for s, so for int s equals 0, s is less than 30, plus s, so I will do std cout of kt, so it's going to take the arguments of t minus s, and then the Hurst exponent. Let's see if these work, because we can't really advance forward if these don't. So I'll clear it, a dot out. Yeah, it didn't work. It worked for some of them. Hang on, let me go ahead and duplicate make the new terminal. I mean, dot slash a dot out. Okay, so this all resulted in a nan. So the first one comes out as infinity. Oh right. Okay, so I'm gonna break this loop. I'm gonna make this 30 minus s because t is the end of it. So let me go ahead and compile this. Wait, what am I doing? G++ R Heston dot CPP std equals C++ 17 else URL clear dot slash a dot out. Okay, so this makes sense. So now that I have that, let me go ahead and code these parameters. So I need to define some variables as well. So the first one I need to define is DWS. So I think what I should do is start off like this. Int t equals 20. Int s, or rather int c. Okay, ig equals 11. Um, actually, wait, what am I doing here? Let me uncomment this out again. So I will set this equal to t. I will set this equal to ig. And then this will also equal ig. So what I want to print out right now is just the parameters. So let me go ahead and break that too. But I want to keep these here because I'm going to need them. Um, so I'm going to come. So let's see. I need a number of steps for this. So that's going to be. Wait, hang on. dt. So we need dt, but we also need ds. So double dt is going to equal t divided by no, t divided by. Let me code these in right now. So int n equals 100, int p equals, or rather, no, double t0 is going to be, I'll call it tf equals 1.0 divided by 365.0. So this is going to be end up being tf divided by t, and then double ds is going to be tf divided by ig. Yeah, so that way we'll be able to do ds. So yeah, first let's integrate this thing. So what I need to do is I'll comment this out. I'll create a variable called double coefficient equals 0 and total equals 0. So the integral is going to be total equals 0 at every iteration. I will take away this break line. I will now I'll keep that commented out. So I'll do if s equals 0 or s equals ig minus 1, coefficient will equal 1.0. Else if s mod 2 equals 0, this will be coefficient equals 2.0. All else, it's going to be coefficient equals 4.0. Okay, so let me now do std cout of coefficient times kt ig minus s h n line. So let me compile it now. Clear a.out. Okay, perfect. So these are working. So now what I can do is get rid of the couts, and then paste this in here. So for that, I will just go ahead and put break. So now I'm going to work on these parameters. So this will end up being double features, or I'll just call it quant. Okay, so it's going to take the argument of, I'll call this ROR, and it's going to take the argument of ds. Yeah, it's going to take the argument of ds. So I will define a window. So int window equals 100. For int I equals window, I is less than ROR.size plus plus I. So I'll need two vectors. So std vector double of hold and store. So hold is going to equal ROR.begin plus I minus window to ROR.begin plus I. And then I will do the volatility. So I have it up here, standard deviation. So I will do store.push back the power of, stdev of hold squared. So then I'm going to come down here and I'm going to do, so I already have the mean and the standard deviation functions. So this is just simply going to be theta equals mean of store, so the mean of the variance, double sigma is going to equal the standard deviation of the variance. And now I need the kappa, so this is going to be let me go ahead and call this V0 V1. So V0 is going to, okay, let me also introduce a variable called lag. So int lag equals 15 prices. So I will come over here and do V0 equals ROR, store dot begin plus lag to store dot end. And V1 is going to be equal to store.begin, store.end minus lag. So now I have to capture the covariance. So this is going to be double covariance. So covar equals 0. Yeah, covar and variance. I'll just go ahead and spell them out because they are the root of everything. So this is going to be for int I equals 0, I is less than v0 dot size plus plus I. So I believe I need their averages as well. So double A1 equals mean of V0, B1 equals mean of V1. So this will end up being covariance plus equals the V0 of I minus A1 times V1 of I minus B1. And then variance is going to be plus equals V1 of I minus B1 squared. So I should add power over here. Yeah, V1, B1. And then I will come down here and do double kappa equals the log, the negative log of covariance divided by variance divided by ds. So let me go ahead and return. Oh wait, no, this has to be a vector. So, or you know what? I'll just make it a map. So map of string, and then it's just a double. So now I'm just going to copy this. Because it'll be more clear than a vector. I'll call this result. So I will do result kappa equals kappa, result theta equals theta, and result sigma equals sigma. And then I come down here and return result. So now that I've got quant, let me go ahead and get the parameters. So, oh wait, so it needs ds. So this will have to be over here. So paste that, and I'll call it params equals quant of data of ROR, comma ds. Okay. So that's not really going to print anything. I'm more interested in what these parameters are. So let me come over here and do for auto and I in params. This will be std cout I dot first, and then I dot second. Okay, so I'm gonna come back over here, compile the code. There's probably gonna be some errors in it. Oh, I guess not. That's good. Dot slash a dot out. Okay, so they look about standard. So yeah, I'll just get rid of this. So clear it. So now, so this is going to be, so let's break this down. So S of t and V of t are going to be placed right here. So let me go ahead and do that. S of t and V of t. So this is the inner loop, but this is the subintegral of that inner loop. So V0 plus this is going to be here. So I'm going to do V0 plus integral is right here. Okay, so let me go ahead and get rid of these little comments. Um, so now that I have all that, I can come here and just simply do uh, total plus equals. So we've got the okay. So we've got k of t minus s. So coefficient times that times this portion. So this is going to be kappa. No. You know what? I'll call this f. So f of kappa times f of theta. Oh wait, I need the initial volatility. Okay, what am I doing? So none of these had the stock price inputted into them, but I do need the volatility for this. So it is going to be. So for example, I would do double S0 equals data of S of data of S dot size minus 1. So that's S0, and double V0 is just going to be standard deviation of data R. So here are my S0 and V0s. I'll call it SX VX. Yeah. So now that I have those, I will do no total's fine. Yeah, that's a simulation of the model. Okay, let's see. Theta minus VS. Time integral. And V0 and VT are out. Oh, okay. Um, so I guess I will just do it like this. Double S0 equals SX. Double V0 equals VX. You guys will see why this works in a minute. I just figured something out. So S0, so let's see. Um, so theta minus V0 times ds plus f of sigma times the square root of V0, 0.5. Okay, so now we have the stochastic parameter. Let's see. So I need math.h include time.h. So I'm just going to use the same stochastic parameter for this. So I'll come over here and do double Wiener int num equals 1.5. No. 150. Double dw equals rand mod 2 times num plus 1 minus num, and then return dw divided by 100.0. So I'm going to come over here and do times d Weiner, and it's going to be independent of this one as well. I know it says to make them correlated, but I want to see like the independence of these paths. Um, so okay, so let me go ahead now and do cout total and line. So hopefully there's no errors or nans or anything in this. I believe I got the integral. So clear dot slash a dot out. Okay, good. That's good. So that's the integral portion of it. That's good. So now I will come over here and do v0 plus equals total times 1.0 divided by 3.0. Just the Simpsons method conditions. So then I will go ahead and do cout v0 and line. Compile it. Run it. Okay, so this is where the problem arises. Okay, well, these all returned as nans except for the first part. Yeah. V0 is not modified in any of those. Let me see what happens if I do equals there. Clear dot slash a dot out. Oh, so it generates a list of nans as well. Okay. I believe it's because the volatility has to be positive. So I will do f max of 0 to the integral. So now, let's see how this responds. Dot slash a dot out. Okay, so now I know what the issue is. It is not changing the random numbers. So I need to come over here and do srand time null. So this will probably give me different parameters. So let me go ahead and compile it. Clear a dot out. Okay, so it's giving me those same yeah, square root, oh, so I wouldn't need ds for that, maybe? Yeah, let's see what happens if I get rid of ds. Um, yeah, I feel like ds would be scaling that value down so much. So clear a dot out. Okay, without ds, these are, that's the thing, they're still like consistent. Let's see if I could, maybe it's to do with the 1.0 divided by 3.0. Well, dx or whatever would be the differential is just ig minus s divided by Because this is going by increments. Okay, I'll add back in ds over there. 1, 2, 4 coefficient. What if I do this? Okay, you know what? I guess I'll keep it. Well, I will do it this way. I will take v0, add it over here, but over here I'll do v0 equals f max of 0.0 of v0. So that way it won't have the negative square root. I think that's what was messing it up. So clear dot slash a dot out. Okay, perfect. We are back in business. Okay, so that's v0. So then so we finished this. Yeah, we finished that. Okay. So all that so yeah, I already got this too, the whole gamma thing. Um, all I gotta do is ds of t now. So this will be s0 plus equals s0 times the square. So v0 0.5 square root times Wiener. I'm just gonna have it run its own independent process. So now what I'm gonna do is come here and do std cout stock price. So this is going to be, I have the stock prices over here. So data of, you know what? I'm going to do this. Double last element. So it takes the argument of a vector x, and it's going to return x of x dot size minus 1. So now let me come over here and do last element of data of s. And then over here, I'll do std cout forecasted simulated price. So this is going to be s0. Okay, so let me recompile this. Clear a dot out. Okay, so it did not a number. Okay, so let's try to diagnose why. So I will do. I already printed this std cout v0 std end line. Let me just double check and see like if it didn't betray me last minute. Clear a dot out. Okay, okay, so the volatility's printed. So let's try to pinpoint. So std cout v0 s0 and that line. Clear a dot out. Okay, so it's been saying nan. Oh. Okay. So over here, I will also do v0 equals f max of v0 to 0.0. So now, let me come and do this. Clear. A dot out. And we got it. We simulated the stock price. Okay. Let me just do one last cleanup of this. Um, I want to make these two correlated. So I'll just come over here and do double rho equals negative 0.3. So then I will add the correlation parameter between them as simply as rho times Wiener, and then rho times Wiener. So now that I have these, I'll go ahead and compile it again. Clear. A.out. Okay, 86, 7, 25, 84. So it's well within a good range, but now I have to so I have to increase my steps and my integral. So that will be so the steps should be I'll set the steps equal to 1000 and the integral equal to 1001. Or no, I'll set the steps equal to like 400 and make the integral more approximate. Then I got my row, initial stocks, everything. So compile it again. Clear. ./a.out. Okay, so that ran it pretty long, so we could see that the price is somewhat deviating a lot away from it. But overall, it is sort of like neck and neck. Yeah, so we stretched it out a little bit too far, but I believe that's the best way to do it. So let's see. Before I go, let me do like a forecast for 5 days. Um, and then I'll make the row like 0.4 so none of them are negative. Um, so then I got that. Run it again. Clear. A.out. Okay, now it's going like really far down. Yeah, it's getting like really high numbers. Okay. Yeah, you know what? Okay, let me undo whatever I did before. Keep the row 1 day. Okay, so time, I'll set time equal to 100. I'll set integral equal to 301. Um, I believe there was something up here that I wanted to change as well. Oh yeah, the num. So this is going to be 15 times 10.0, and then I'm going to run it one last time. So compile it. Clear. A.out. Okay, so now it's sort of like back to normal. So yeah, I guess I'll just leave it at that. So that is the Rough Heston model coded in C++, and it's good for stocks which have Hurst exponents of less than 0.5, meaning they're mean reverting. So yeah, I thank you all for watching this video. I'm going to keep coming out with more and more good quant content. Stay tuned, and peace out.